Welcome to The Explainer. Today, we are unpacking an incredibly insightful deep dive straight from the AWS architecture blog. We're talking about the real-world headaches of scaling massive stateful systems efficiently. Imagine an ad-serving infrastructure, right? One that handles millions of requests every single second and drives literal billions of dollars in revenue. It's huge. But as with any system at that kind of immense scale, it brings some serious growing pains. Okay, let's dive into this. 52 days. Seriously, I want you to just let that sink in for a second. We are not talking about the time it took them to build their platform from scratch. No, this was the agonizing amount of time it used to take this engineering team to onboard just one single new client. Imagine closing this massive enterprise deal, popping the champagne, everyone's high-fiving, and then having to look your brand new partner in the eye and go, "Great, we'll see you in 2 months."
And it actually gets weirder. While it took 52 days just to get a client online, the servers they were running on spent over 98% of their time completely idle. Average CPU utilization sat at a staggering 3%. Memory, barely touching 19%. So here's the central mystery of our explainer. Actually, scratch that, it's more of a glaring contradiction. How exactly do you fix an infrastructure that is bleeding cash on massive idle servers, yet is so rigidly built that it bottlenecks your entire onboarding pipeline?
Section 1. The Cellular Architecture Trap.
Under their old model, the team used something called cellular architecture. Basically, every time a new client came along, they were handed their very own, completely isolated IT universe. The whole shebang. A dedicated AWS account, a dedicated application load balancer, dedicated Amazon Elastic Container Service clusters. Now, on paper, this sounds great, right? It provides incredible, hermetically sealed isolation for the client. But structurally, it was the exact reason everything was grinding to a halt.
Let's look at the 5 operational nightmares this setup created, because it was a lot. First, the scale problem. Just 18 clients meant managing 118 separate targets. The operational overhead was absolutely suffocating. Second, the efficiency problem. Paying top dollar for servers that were, as we said, 98% idle. Third, the onboarding problem. Spinning up all those VPCs, IAM roles, and networks took 52 days. Fourth, the scalability problem. If traffic spiked, they couldn't just casually scale up. They had to spin up an entirely new cell and migrate the client over. This meant they literally couldn't run concurrent top-tier live events. And finally, and this is the craziest part, despite all these rigid silos, they somehow still suffered from the dreaded noisy neighbor problem.
Now, you might be wondering, wait a minute, if everyone gets their own completely isolated cell, how on earth are there noisy neighbors? Great question. Well, their ad-serving platform is a stateful service. It loads and maintains massive data sets directly in memory rather than constantly fetching from a database on every single request. So when tenants share any underlying cluster infrastructure, their in-memory data fights for the exact same heap, the shared pool of server memory. If one tenant suddenly loads a huge data set, boom, it hogs that pool, triggers an out-of-memory condition, and instantly crashes its neighbors. They desperately needed isolation for sure, but this cellular model was completely choking them.
Section 2. A hybrid multi-tenant solution.
So the fundamental shift here was moving away from that old, painful model of dedicated AWS accounts for every single tenant. Instead, they transitioned to a hybrid model, cluster-level isolation within shared AWS accounts. Basically, they're pooling their resources to solve the efficiency and onboarding headaches, but they're drawing very hard boundaries at the cluster level to protect that precious in-memory state.
Section 3. The 3-level cloud hierarchy.
To make this hybrid model actually work at true enterprise scale, they designed what I like to call a Russian nesting doll architecture. It's pretty brilliant. Let's break it down. Step 1 is your outermost doll, the tier. This is just a logical grouping of tenants that share a common infrastructure footprint based on their traffic, like high, standard, or low transactions per second. Step 2, nestled right inside the tier, is the cell. This acts as the AWS account boundary. And finally, Step 3, nestled inside the cell, is the Infra Group. This is your self-contained operational unit, your VPC, a load balancer, and your ECS clusters.
So the absolutely crucial point is how they handle the compute layer inside that infra group. They give every single tenant their very own dedicated Amazon ECS cluster. Because the cluster is exclusively single tenant, those resource limits apply only to them. That terrifying noisy neighbor problem we talked about, the shared heap crashes, boom, completely eliminated. But because these clusters live inside a shared infra group and cell, they don't have to go through the nightmare of spinning up a brand new AWS account just to onboard someone.
And this right here is the light bulb moment. It gives their engineers two completely independent scaling levers. Check this out. If your application load balancer hits its limit, which is usually about 50 tenants, you don't panic. You just add a new infra group inside your existing cell. But if you start hitting hard fundamental AWS account limits, like maxing out your elastic network interfaces, then you just add a new cell. This framework tells you exactly what to do and exactly when to do it.
Section 4. The pre-integration secret.
I want to slow down here for a second, because this direct quote from the architect is basically the whole ballgame. This step happens at tier creation, not at tenant onboarding, and that distinction is the architectural heart of the design. Keep that in mind. They are shifting all the heavy lifting away from the frantic moment a client signs a contract and moving it all the way up to when the system is originally built.
So here is the secret sauce. In the old days, every new tenant needed their own custom wiring to downstream services. We're talking VPC peering, transit gateways, the works. Now, they use AWS Private Link to establish that connectivity just once, all the way up at the top tier level. When a new tenant is dropped into an infra group, they instantly inherit all those downstream connections. Just like that. Onboarding is no longer this exhausting multi-week infrastructure project where you're pulling your hair out. It's literally just a configuration change.
And tying this whole brilliantly pre-integrated web together is Amazon Route 53. By using Route 53 weighted routing, they can seamlessly shift traffic across load balancers spread out over multiple AWS accounts. If they need to scale out and add a brand new cell, they just add a weighted record. The client's DNS doesn't have to change at all. The backend can literally scale horizontally across thousands of accounts, and to the end user, it is entirely invisible. Section 5. Massive efficiency and isolation. Okay, remember that agonizing 52-day wait time we talked about at the very beginning? Well, by pre-wiring their infrastructure and giving tenants dedicated clusters inside shared accounts, they plummeted that onboarding time down to just 7 days. That is an astonishing 86% reduction. And honestly, those 7 days, they are mostly just testing and validation at this point, since the infrastructure is essentially sitting there waiting for the client the moment the ink dries on the contract.
And alongside that massive save on time, they achieved an 80% reduction in actual infrastructure setup steps, plus an 80% drop in manual engineering effort per onboarding. It's wild. Their feature release time shrunk from days down to just a single day. They successfully co-located up to 100 tenants per AWS account, massively improving their resource utilization, all while maintaining that ironclad cluster-level isolation they absolutely needed for their stateful data. It's truly a masterclass in challenging your own architectural assumptions. Silos offer safety, sure, but at a terrible, terrible cost to your agility. By separating the creation of the infrastructure from the onboarding of the tenant, they completely reclaim their speed. So, I'll leave you with this to think about. Is your multi-tenant architecture waiting 52 days to scale, or are you ready to build a hybrid? Thanks so much for joining me on this explainer, and I'll catch you on the next deep dive.